So now we're going to look at exponential functions, which follow the form f of x equals a to the x, where a is any real number with a couple conditions. First, a has to be a positive value, must be larger than 0, and it can't be 1. The second of these is actually easy to explain. Well, because if a is 1, we simply have 1 to a power, and 1 to any power is 1, so that's really a trivial case, and we're not concerned with that. The second is if a is less than 0, or if a equals 0, of course that's not, and also a trivial case. But if a is less than 0, it's also not very interesting, because assume it's -1, for example. -1 squared, well, that's just 1. -1 cubed, well, that's -1, so we jump up and down. We'll jump all around in the graph. Also, -1 to the 1/2 power is undefined. Well, -1 to the 1/3 is defined. So there's all sorts of issues if a is a negative number. So just remember, a has to be a positive number, but not 1. There's two cases. If it's greater than 1, well, we have exponential growth, where it grows along this path. The second case is if a is between 0 and 1, well, we have exponential decay, where it falls like this, with the mirror images of each other around the y-axis. Now, let's look at the domain, range, intercepts, and horizontal asymptotes. For both of these, the domain is all real numbers, from -infinity to +infinity. The range for these is from 0, non-inclusive, to +infinity. The intercepts, well, there's no x-intercepts, but the y-intercept is the point 0, 1. And that's really important. That's always the case. And finally, there is a horizontal asymptote, and that horizontal asymptote is y equals 0. Let's quickly compare the equations y equals 1/2 to the x to the equation y equals 2 to the negative x. And this is the case that, as we discussed previously, of a is greater than 0 but less than 1. Of course, 1/2 fits that criteria. Now, I want to point out that, well, our overall goal of this is to show they're exactly the same thing. And that's because 1/2 is the same as 2 to the -1. Therefore, 1/2 to the x power is the same as 2 to the -1 to the x, which is the same, so I have 1/2 to the x, and then is the same as 2 to the negative x. So that was shown that they are the same thing. And often they'll be used interchangeably, but we need to recognize that they are the same thing. Our general case of the equation or the function is a to the x. They'll often, just to avoid the hassle of writing the fractions and stuff, they'll just use 2 to the negative x.